everyone, welcome to the next session of Strength of Materials. In this session, I am going to solve question 6 of Macaulay's method. Find slope and deflection at point C for the beam loaded as shown in the figure below. Assume moment of inertia and modulus of elasticity as I and E respectively. So the value of I and E is not given. I'll just calculate and get the answer in terms of I and E. Now if you look at the beam, there is again a UDL given to me, but here it is given at one end of the beam. So I can draw the section over here and solve the problem very easily. The first thing that I'm going to do is draw the FBD. At point A there is a hinge, so there will be a reaction VA. This is my point B. C, there is a moment here clockwise 8 kilonewton meter. A to B has a UDL, so 4 into 4 becomes 16. This distance will be 2 meters and 2 meters from both the ends. At point D there will be a reaction VD because there is a roller. This diagram will be useful for calculating the value of VA and VD only. Next, for calculation of slope and deflection, I need to draw another diagram which will contain the slider. So this is my point A. Here there will be reaction VA. Now I am going to draw the same UDL here. Don't convert this into a point load because the section has to pass through the UDL. So this is my section XX. For the first time I am drawing the section to the left of the beam and I am going to turn all the forces opposite. So this is my point D, which will be VD, and C will have a moment 8 kilonewton meter. Now D point will be at a distance of X. The point C will be at a distance of, this is 2, so this will become X minus 2, and this distance is also 2, so B will be at a distance of X minus 4. Just be very clear that we have to mark the distance of the points from the slider. So from the slider I have to calculate the distance D, C and B. That's what I've done. Now I'll start with this FBD and I'll calculate the value of VA and VD. I'll use a condition of equilibrium. Summation of force in y direction is 0. Upward forces will be considered positive. I have VA going upward, 16 going downwards, and I have plus VD is equal to 0. So I have therefore VA plus VD is equal to 16. This is my first equation. Next I'll use summation of moment about any point is equal to 0. Say I'm taking about point A and I take clockwise as positive. So the first thing that I have is 16 turning clockwise. So therefore 16 into 2. Next I have 8 going clockwise, so plus 8. Next I have VD going anti-clockwise, so minus VD into 8 is equal to 0. So therefore I get the value of VD as 5 kilonewton. When I get the value of VD and I substitute in this equation, I'll get the value of VA as 11 kilonewton. So I'll just mention over here VA is 11 kilonewton and VD is 5 kilonewton. Next I'm going to write the moment curvature relationship, which is mx is equal to EI d square y by dx square. Now I will have all the forces turning towards the slider XX. Now in this case what I can do is I can quickly say that anti-clockwise forces will become positive. If you want you can still continue with clockwise being positive, but I will switch over to anti-clockwise being positive. It is just my sign convention. If you want you can change it. So here I'll write down this VD turning anti-clockwise, so I'll have 5 into X. Now I'm going to write the distances. If you look carefully, the distance is going to start from D now. So at this point X will be 0, at C my X value will be 2, at B my X value will be 4, and at A my X value will be 8. So this is how I'm supposed to mark the distances. Now here I'll write the domain from 0 to 2. Next at point C I have this 8 kilonewton which is going clockwise, so it will become minus 8 into x minus 2. You can see the distance is x minus 2 from this section, raised to 0 because it is moment, and the distance is from 2 to 4. Here no other forces, so I'll switch over to B to A portion. Here I have this UDL whose value is 4 kilonewton per meter. So I am going to multiply 4 into x minus 4. So this will be 4 into x minus 4, and this will be the load. So when I place the load, it will be at half of x minus 4. So x minus 4 by 2. Now this will turn clockwise. So I'll write a negative sign over here. The distance will be from 4 to 8. So this is my moment equation. Next I'm going to integrate this twice and I'm going to get the slope and deflection equation. So I'll write down integrating twice. EI dy by dx is equal to C1 plus 5x square by 2 from 0 to 2 minus 8 into x minus 2 from 2 to 4, and I have 4 into x minus 4. You see this is square, so it will become cube upon 6 from 4 to 8. This is my equation 2, which is my slope equation. Again, if I integrate, I get EIy is equal to constant of integration C2. This will be C1 into x plus 5x cube upon 6 from 0 to 2 minus 8 into x minus 2 square by 2 from 2 to 4, and last term will be x minus 4 raised to 4 upon 24 from 4 to 8. This is my third equation. Now I have to apply the boundary condition. I can see at D my value of x is 0, y is 0. At A the value of x is 8 meter. Here also y is 0. So I will start with the point D. I will write applying boundary conditions. First one is at x equal to 0 at point D, y will be 0. Now D point is over here, so I'll just write up to this point. So I'll write down therefore 0 is equal to C2 plus C1 into 0 plus 5 into 0. Therefore my C2 becomes equal to 0. Just be careful that this time we are walking from right to left and not left to right. So no other changes. Next boundary condition, at x is equal to 8 meters, y will still be 0, which means I have to write the entire equation. So therefore left hand side is still 0 is equal to C2 is 0. Here I'll substitute C1 into 8 plus 5 into 8 cube by 6 minus 8 into 6 square by 2 minus 4 into 4 raised to 4 by 24. So therefore I get the value of C1 as minus 30. Now I'll substitute C1 and C2 in equation 2 and 3 and I'll get equation 4 and 5. So here you can see 4 and 5 are my slope and deflection equation. Now in the question it is asked to only calculate the slope and deflection at point C. So I'll just locate my point C. At C my value of x is 2 meter. So I'll just write down at point C x is 2 meter. So I'll just solve. Now 2 meter means I need to stop here and here. So I'll substitute and get the answer. EI dy by dx at C is equal to minus 30 plus 5 into 2 square by 2. Therefore I get the value of dy by dx at C as 20 upon minus 20 upon EI radians. And next I have to calculate the deflection. So I will substitute. I'll get EI yc is equal to minus 30 into 2 plus 5 into 2 cube upon 6. So I get the value of yc as 53.334 upon EI meters. Okay, I get a negative sign, meters. So this is how you calculate the slope and deflection. This numerical was very simple. I just wanted to tell you how to solve for UDL. So I just hope you understood the numerical. I'll see you in the next session. Thank you.